This is Mr. Wright. Today we're going to go over how to find the measure of interior and exterior angles in a polygon. So we're going to look at polygons with different numbers of sides. So in order to figure this out, one thing that we already know is that any type of triangle that we have, so it doesn't matter what the triangle looks like, all of the angles in that triangle are going to add up to 180. That's your triangle angle sum theorem. So if we know that, then we can break other polygons into triangles to figure out what all of those angles would add up to. So for example, in like a quadrilateral, if there's 4 sides, you can break that into 2 triangles. And if I know that it has 4 sides, 2 triangles, the total number of degrees would be 180 times 2. So that would be 360. If there's 5 sides, then I would have 1, 2, 3 triangles if I break it up. And 180 times 3 equals 540. If there's 4 sides, 6 sides, that would break into 4 triangles. So the total degrees would be 180 times 4, which equals 720. So if you guys look at the 3 examples that we looked at, we had 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles. Each time the number of triangles was always 2 less than the number of sides. So if I had 10 sides, then that would be 8 triangles. So it's always going to be 2 less. So the formula that we could do, if I said that n equals the number of sides, if I did the number of sides minus 2, that would give me the number of triangles that you would create. And then however many triangles we have, you multiply by 180 because there's 180 degrees in a triangle. And this would give me the sum of the interior angles of any polygon. So the number of sides minus 2 times 180. Is what all the angles in a polygon would add up to. So let's look at a couple of examples. Okay, so in order to figure out the sum of interior angles, the first thing we need is the number of sides. So if I have 10 sides, I'm going to do 10 minus 2 times 180. I know that 10 minus 2 is 8, so I'm just going to type in 180 times 8, or 8 times 180 to get my answer. That equals 1440. So all of those angles would add up to 1,440 degrees. If I had a 12-sided polygon, so that means that there's 12 sides, I do 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1,800 degrees. So all the angles would add up to 1,800 degrees. The next 2 examples, I give you what all of the angles would add up to, and you have to figure out, well, how many sides would that be? So I don't know the number of sides. So we start with our formula, and we know it equals 2340. So with this type of problem, we're going to work backwards. So first, if we're working backwards, so when we're going forwards, the last thing that we do is multiply by 180. So if I'm working backwards, I'm going to first divide by 180. That leaves me with n minus 2 equals 13. So the 13 represents like the number of triangles that would be in the shape. So we know that the number of sides minus 2 equals the number of triangles. So if I'm working backwards, I would add 2 to this number. And that would give me that there would be 15 sides in that shape, in that polygon. So you just are working backwards. So you divide by 180 and then add 2. So this one, I have 1620. So I just do my formula equals 1620. I divide by 180. Again, get 9, and then so there would be 9 triangles if I divided the shape into triangles. So that means if I add 2 to that, it would have 11 sides. All right, so if I have a problem like this, the first step to do any problem like this, if it gives you like angles on the inside of a polygon, is you have to figure out what would all those angles add up to. So before I can even start, I need to do my formula. The number of sides minus 2, so if there's 5 sides, 1, 2, 3, 4, 5, minus 2 times 180, 3 times 180 would be 540 degrees. So all of these angles would have to add up to 540. Because I have one of my angles missing, I would just subtract the other 4 angles from 540. Now we get that missing angle would have to be 90. The next one, kind of the same deal, you count up your number of sides. So all of these angles, if I do my formula, if there's 7 sides, 7 minus 2 is 5, 5 times 180 is 900. All of these angles would have to add up to 900. All of these angles that they give me add up to 800. So if I do 900 minus 800, I get 100. So this last angle, the missing angle, would have to be 100 degrees. To solve for x, then I know that x and y form a straight line, so they're a linear pair. So x would have to be 80 because those two angles have to add up to 180. One more example, this is dealing with equations. So in order to answer this question, I first have to know what would all of these angles add up to. So because there's 5 sides, I would do 5 minus 2 times 180. That would give me 540. So before you can do a problem like this, you have to know what all those add up to. So they're all going to add up to 540. So then you just write out your equation and you do all 5 equal 540. So what I would probably do is just combine my like terms first. Add all those, I get 22x. Then add all of the constants. Make sure you don't forget about the 90. So I add all those numbers together and I get 100. So then you can solve for x and you can just plug x back in to find all the missing angles. All right, so those are my interior angles. We have one more thing to look at, the exterior angles. So exterior angles are angles on the outside of the triangle. So with like a quadrilateral, like a square, if all the inside angles are 90, all the exterior angles would be 90. If I add those 4 90-degree angles together, I get 360. With a regular pentagon, all the inside angles are 108. All the outside angles would have to be 72 because they're on straight lines. So they would have to add up to 180. So 180 minus 108 is 72. If I add up all those 72s, I get 360. So all of those outside angles add up to 360. Then with a regular hexagon, all the exterior angles would have to be 60 because it would add up to 180. If I add up all those 60s, I get 360. So the important thing here is that the exterior angles of any polygon, all of the outside angles are always going to add up to 360. So it doesn't matter how many sides it has, all the outside angles add up to 360. So this is that theorem that supports that. Each one is going to be 360. So if you had a 17-agon, so a 17-sided polygon, doesn't matter how many sides it has. The exterior angles are always going to be 360. So if I know that, then we can answer a question like this. If a regular polygon has an exterior angle measure of 60, so if one of them is 60 and if they're all the same, to figure out the number of sides, I could just do 360 divided by 60, and that would tell me that this polygon has 6 sides. So then with this type of information, if you have a different type of problem, just remember like, doesn't matter if it's dealing with exterior angles, all those angles have to add up to 360. So that's the main thing that you have to know. So whatever you fill in the picture, all those angles have to add up to 360. That's the main thing.